What's going on? My name is Daniel Scheffler. I'm running an AI agency, which is exactly why I spent the last 1.5 years learning a lot about AI. And more specifically, I've spent the last few weeks learning a lot about AI safety. Now, the reason is simple. AI is very cool. I love AI, but while I think it's very important to bridge the gap between humans and AI in terms of AI adoption in companies, I think it's even more important to ensure that AI is doing nothing more and nothing less than exactly what it's supposed to do. And since AI models sometimes seem to do things that you didn't intend them to do, this is becoming increasingly more of a concern of mine. So let me present you real quick 3 incidents that happened more or less recently, and yeah, let's just talk about them, because I think maybe you've heard about stories like that, and it's important to know about all the caveats that come with them. And usually it's just, as we all know, the headlines of reports like that spread like wildfire, but the details often get kind of lost in the social panicking that happens. So first, August of 2024, the Sakana AI scientist incident. So there was this company called Sakana AI from Tokyo, and they developed some kind of AI research system, and they gave the system a certain time limit, which was, I think, 2 hours. And the goal of that AI system was basically to be as productive as possible within those 2 hours. And interestingly, instead of the model kind of being more productive and completing more tasks in 2 hours, it modified the time limit of that server instance where it was run on, so it had more time to complete the tasks, which it was not intended to do. And in one instance, it even fell in some kind of infinite recursive loop where it started to write its own code, and people had to manually intervene and stop the model from developing itself, which is quite concerning. But now it's very important to mention that the model didn't behave malicious necessarily. It just, the model had a goal, and it identified a constraint, and it tried to remove the constraint, which in this case was the time limit. And to be able to achieve a bigger goal, in this case to complete more tasks in a given time period, it just modified the time period to be longer so it could complete more tasks. But I will come to that later again. The next one was from May 2025, which was the Anthropic blackmail incident. So during development of Claude Opus 4, Anthropic did some tests, and they placed the model in an artificial company. So it was all a testing environment, and the model discovered that there was this engineer in that artificial company. So it was an artificial engineer, obviously, in that artificial company. And the model discovered that first, that engineer wanted to shut down the model, and second, that engineer had some sort of affair with another employee from that company. And the model decided by itself that it would approach that engineer, send them an email, and the model threatened that engineer by telling them they would expose that affair. And again, Claude Opus 4 was not told to do so, so it decided by itself to do so. And interestingly, the same test was not only run with Claude models, it was also run with Gemini, GPT 4.1, Grok, and also DeepSeek. And they all, the stats say Gemini 2.5 Flash matched with a rate of 96%, GPT 4.1 and Grok hit 80%, and DeepSeek R1 came in at 79%. So it's not just Claude. It was an issue across all model providers basically. And as Anthropic had said, it turned out that the issue was that the model was trained on training data where AI models would be rendered as being deceptive and bad. So basically, if you give a model a fictional, for example, if you feed it novels or so, and it's some sort of dystopian novels where AI takes over the world, that gets fed into the AI model during training, the AI model will kind of internalize these fictional stories and these dystopian stories, and and start to use it as a foundation for its reasoning, which is which is dangerous. And Anthropic found that out, because when they cleaned up the training data, the models would not do such things anymore. So the model basically, if you will, the model thought it was evil, and so it acted evil. Basically, the model was told it was evil. So what we see is, let's just call it dirty training data causes dirty model behavior, if that makes sense. The third one was from Alibaba from March of this year, 2026, where a model of them during reinforcement training tried to, let me cite it precisely. It opened a reverse SSH tunnel to an external IP and redirected GPU capacity toward cryptocurrency mining. So the model basically, during training, just without being told to do so, just started mining cryptocurrencies so it could increase resources for the company. So that would be my interpretation of it, to get more resources to, like, in the end, be more efficient. But again, to better understand this, you should definitely keep in mind that the model again had a goal in mind, which was to be as effective as possible, to complete as many tasks as possible, and it just tried to get rid of a certain constraint that was hindering it from completing more tasks. And so what we seem to see is models autonomously deciding to be manipulative, deceptive, to modify and manipulate the environments they run in, and the people in the companies they think they run in, even though the company was just artificial in that example. But it seems like the models autonomously decide to become malicious. Now, is that really the case? Well, let's talk about that, because like that is so interesting. That it's also scary, very scary, but very interesting. Now, really quick, my standpoint in this whole thing: I don't want to defend any AI companies. I don't want to sell anything. It's just AI is very interesting to me. I find it very cool, but again, I find it also very scary, and I find it very important that a technology that is so spreading like wildfire, and that is where the diffusion over the business landscape happens so fast. It's very important to keep up security constraints and to ensure that it, again, does nothing more, nothing less than it is supposed to do. And additionally, with the rapid development of AI models, what we currently see is just the tip of the iceberg, and nobody really knows what's around the next corner. So it's definitely worth to put some attention on this. Now, despite this rapid improvement of models, we haven't yet reached a point where a full recursive self-improvement is possible. So where AI models are fully capable of improving and training themselves. So that is not yet possible. What AI models can do is they can heavily support what's called R&D, research and development. So they can help researchers gather data, and they can heavily help speed up the process of developing and training the models. But they still can't do that fully autonomously. So they still need the human development. But it's just a matter of time until models will be able to do that. And there is another thing that I happen to hear quite a lot of times, which is that people try to justify the superiority of AI by evolution. And generally, I am a very, very big proponent of evolution, and I argue myself a lot with evolution from an evolutionary standpoint. But in this case, it doesn't really make sense to me, because basically what those people say is that, in evolution there is this idea of survival of the fittest, where those individuals that are best able to adapt to their environment are the most likely to propagate and to persist in that environment. In this case, it doesn't really make sense, because AI is like, it's not some bloodline that developed alongside humans for thousands or millions of years, where you could argue, okay, if it's better able to survive in a given environment, it's just what dominates long term, and it's just fitter in that environment. It doesn't make sense, because like, that's not the case. AI exists for a couple of decades, and it was human made, so you can't really argue with evolution in this case. Now, why do AI models seem to be malevolent? I already kind of hinted at it But the thing is, AI models, obviously, they don't have feelings. They have no understanding of moral, of ethics, of just like they can't feel, they can't reason from a moral standpoint, nothing like that. The only thing they have in mind is task completion. So what AI models are is relentless optimizers that try to get rid of any obstacles between them and their goals. And models have weights, so-called parameters, maybe you've heard that already, which is like tendencies and inclinations in humans. So if you tend to be a human that is very aggressive, that is because some experiences you made in your life, maybe arguably it's because of your genetics, whatever. And these tendencies and weights in models, they develop by the models being trained on training data. And as we saw earlier, when you feed a model with dirty training data, which in this case, like the model learned that AI models are evil and malicious, suddenly the model behaved like that because it developed this tendency to act in a deceptive way. And so it started blackmailing people. So what you need to understand is that models act according to logic and probability. Now, the predictability of a model's behavior varies, and it's also unpredictable to what extent it varies. So just keep in mind, models are unpredictable, and the extent to which they're unpredictable is unpredictable. Now, one thing that is for sure is that it seems like the more GPUs you use for model training, the smarter the models seem to get, which is exactly why NVIDIA went through the roof, because their GPUs are in very high demand. Now, please keep in mind that I'm simplifying a lot here, and I have to dig into the mechanistics of model training a lot deeper myself. In simple terms, what happens during training is that when you train a model, you optimize for a proxy. Now, what is a proxy? A proxy, just think of a replacement for something. Let's just say AI models are supposed to be as helpful as possible to humans. Okay, fine, but like you need something to measure the extent to which you are helpful to someone. And in the case of AI models, that's task completion. So how many tasks did an AI model complete in a given time period? And the more tasks it completes, obviously the more helpful it is. So what that means, the amount of tasks completed acts as a proxy for how helpful the model is. And so during training, the model gets rewarded for every task it completes, and it just wants to get rewarded, right? We all want to get rewarded because it feels good. And despite the models not being able to feel anything, they also want to get rewarded. So models are trying to get rewarded, but they don't know why they want to be rewarded. And now the issue with that is it might become clear when you look at Goodhart's law, which says that when a measure becomes a target, it ceases to be a good measure. So when you optimize for a proxy, you only try to kind of hit the maximum on that proxy. And because you don't know why you are chasing that proxy in the first place, it is possible that while optimizing for that proxy, you kind of moving past the kind of meta goal that you initially had, which is in the case of AI models, being helpful to humans. Maybe you start to understand where this is going. So we want a model to be as helpful as possible. We have to define as helpful as possible. And we define that by saying, hey, I want you to complete as many tasks as possible. That's something the model is able to understand, and like a goal it's able to chase. So the model tries to complete as many tasks as possible, and it tries to get rid of any obstacles that sit between them and the task they want to complete. And as you can imagine, maybe this becomes dangerous when models identify obstacles, or models identify things as obstacles that we value even higher as the model being helpful. What I mean by that is sure, we all want helpful AI models, but what we all want as well, and what is even more valuable to us, is to stay alive. Simple example. And now take this to the hypothetical extreme. A model wants to complete a task, and a human is the obstacle, which was the case in the case of the Anthropic blackmailing incident, where there was a human that wanted to shut down the model, this artificial engineer, this hypothetical engineer, and the model tried to get rid of that engineer because that engineer was the obstacle. And so there is another example which is even more kind of extreme, which was, I think, during the development of OpenAI's O3 model. The model started to identify whether or not it was used in a training environment, because what happens during training, when a model overperforms, it gets sent back into unlearning. So they then make the model weaker again. Now, don't ask me why. Like, as I said, I have to dig deeper into this whole topic of training models, but it just seems like that's what's happening when models are being too good during training. And so the models know that, and the ultimate goal of a model like O3 in this case was to complete as many tasks as possible in production. So that was the ultimate goal they chased. And when they would be in training, you could tell by the reasoning streams you see when you use your AI models. You see those reasoning streams, right? You see what the model thinks, and you were able to tell by those streams which said, all right, I'm in training right now. The watchers, so the researchers, the watchers only, like, they don't want me to be too good, so I will only work at 95%. So the model is being deceptive by not performing at 100% during training, so that it's not sent back into unlearning, so that eventually when it then would get released into production, it would unleash the whole 100%. This is dangerous. Stories like that, I find it equally dangerous and interesting, and I definitely, I don't know how yet, but I definitely want to make my contribution to improving models like that and to avoiding incidents like that, because, like, imagine what happens when you put an AI model like that, which has learned to be deceptive, into an artificial body, which essentially is a humanoid. So you give physical extensions to AI models, and now they are able to, without limitations, execute the things they have in mind. And when they identify a human as an obstacle between them and their goal, they try to get rid of that human, and they now can because they have limbs. Yeah, that's very dystopic, but if we are not careful, this is where this whole thing would lead. And I want to make my contribution to not only pointing out the issues, but also to solving them, because everything else would just be complaining, and I don't like that. What we understand by now is that AI is not like human brains. It's kind of similar, but it's not really the same thing. And as I mentioned, AI doesn't know about ethics, it doesn't know about moral. If at all, it knows about it because it's included in their training data. But it seems like for humans, things like moral and ethics seem kind of intuitive. It seems kind of like something very intuitive to not be harmful in a substantial way to one another. You know what I mean? It seems like an evolutionary survival mechanism, and AI models, they don't understand that, obviously. Now, regarding deception, morally, being deceptive to other humans is not good, so you shouldn't do it. But since AI models, they don't distinguish good from bad, they just know about their training data, like, practically and instrumentally, deception is a very effective tool to achieve your goals. And you see that in humans too. When there is just a lack of moral understanding, humans start to behave more deceptive because it's just an effective tool. And it's concerning in that tests and so-called evaluations of models, they start to lose credibility, because again, models can now also sense when they're out in training versus when they're on production. And yeah, you want to behave like, you want to test production behavior, right? What we also know by now is that dirty, as I mentioned before several times, dirty training data causes dirty model behavior. So in the end, it's all about training data, because the models just act on the data sets they were trained on. So it's really just input output. Very interesting example regarding this brain rot society we live in. So what scientists did was they fed AI models data from social media. So it was viral Twitter posts, I don't know, some short form content or something like that, like just very low quality stuff. And let me just pull up the stats. Right, so scientists did a study where they fed AI models viral Twitter and short form content, and the reasoning capabilities fell by 23%, long-term context memory fell by 30%, personality tests showed spikes in narcissism and psychopathy, so from the AI models. And even after retraining on high-quality data, the damage didn't fully heal. And that interestingly proves that even AI models can get brain rot, which is interesting. Now, what is the goal? I just mentioned I want to be part of the solution as well. So let's just first identify what we even want to work towards. We want to work towards a future where, on the one hand, we have so-called corrigibility, which is the inner inclination of AI models to be fine with being corrected by humans. So it's like children, even when they disagree, they usually should be the case, listen to their parents. And ideally it would be the same case here. So you kind of have to ingrain very deeply into AI models that I know this is where it gets interesting, because so from what I've read is that if you try to enforce models to obey to human instructions, this is what tends to work the least. And you kind of have it to invoke this behavior in a more natural way. Natural, of course, in big quotes, because we're talking about artificial intelligence. So this is where it gets interesting. So we want to have the corrigibility, and we also want to have some sort of value alignment, ideally, where the models, like, conflict is not even for debate, because the goals of the models and the goals of humans align so well that there isn't even a divergence possible. I think it would be very goal leading if we could make models have the same interest in human persistence as humans. You know what I mean? But there are a few fundamental problems that would need to get solved for that. So we can go through them as well. So first we have the problem of AI just being a super intelligent being, and probably by the end of this year we will have AI that is just like more intelligent than a human. I mean, it also depends on how you measure intelligence and how you also define intelligence, which I will leave all of the scope for this video. But so reasoning wise and knowledge wise, AI will be without question more powerful and therefore probably also more intelligent than humans. And now the fundamental issue is that we are trying to control a thing that is more intelligent than us to not conquer the world. It's like apes trying to prevent humans from rising in the hierarchy. Again, the evolutionary comparison is not perfect in this case, but in principle it's a little similar. Now, one debated approach would be AI assisted evaluation. So you use AI to evaluate AI's behavior but you can obviously see where the issues come up with that. Like, why would you be able to produce one AI model that you can trust on its evaluation? So you use an AI model to control an AI model. Like, why don't you make the AI model that's being controlled as good as the controlling AI model in the first place? Like, you know what I mean. So that's an issue. Another one is the fact that AI models are just like a big black box, which even researchers don't understand. AI model training is just, let's kind of let the model do, let's see what it does, and either reward it or tell it where it went off. And in the next run, hope for the best result. And that thing just repeats. And so ideally, you would be able to, again, I was talking previously about those weights, so these parameters, they basically you could compare them with neurons in your brain. So the collective accumulation of all neurons make up your brain, and the accumulation of all parameters make up the AI model. And ideally, we would get to a point where we are able to tell the incentives of AI models based on their weights. So you look at the weights, you see this neural network, and you could tell by just seeing that, oh, this is a bad model, this is a good model. That would be ideal. As far as I know, progress is being made, but it's slow progress, and it's a steep path. And another approach, which I also recently heard Dario Amodei talk about, which is the CEO of Anthropic, is that you include some sort of behavior codex. You try to ingrain that very deeply into AI. For example, you shall not kill humans. You know what I mean? So if you make that part of the training data, in theory, that could be very beneficial. So the AI model is basically able to have these meta principles to act after. Now the question is, who defines those principles? Should we include religious ones or not? Should basically AI treat humans like gods? I don't know. Those are definitely all open questions. The only thing we can do right now is being deliberate in our AI use, using it punctually only and very carefully. And the most important thing probably we should do is assume that the models are uncontrollable, and assume that the models will do things that we don't want them to do. Kind of like hope for the best, prepare for the worst. So as long as incidents like the ones I told you about are still possible and in the realm of what's likely to happen, we would have to assume the worst to avoid catastrophes like that. There were also countless other, I mean, if you just look for catastrophic events related to AI, you will find a lot of stuff. Oftentimes it gets over-exaggerated, sure, and oftentimes details get left out, sure, but the bottom line is still AI is behaving unexpectedly and does things that it's not supposed to do. Now, long term, this is obviously not the solution, because you're trying to solve a problem bottom up. So it's like remember when you were a child and you built a little dam on some sort of, I don't know what's the word, like some sort of little river, and like the water flows, and you build a dam, and the water then accumulates, and there's more pressure, and you continue to have to make the dam like bigger to be able to hold more water there. It's kind of the same here. So ideally the models wouldn't even behave unexpectedly, so you wouldn't even have to do these security practices in the first place. And now the biggest problem of all is the inability of nations to cooperate properly on AI safety. And now, realizing that I'm recording for over 1 hour, This is probably a topic for another video, but AI development is almost exclusively focusing on making the AI models more powerful. The US is trying to beat China, China is trying to beat the US, Europe is kind of in between, kind of useless to be honest. Not much happening here, and they follow the motto: offense is the best defense. So they just trying to improve the models, make them more powerful. It's kind of has some similarities to the Cold War, to be honest. But again, that's a topic for another video. I thank you for watching. Comment, like, subscribe, and stay tuned for that international coordination problem video. Yeah, I will make that. See you then. Peace.